This is Concepts Video 3 for the GeoSketch application. This is actually a remake of the video. The original version resulted in a file that was too large to conveniently download, so we've broken it into 3 pieces. We'll continue our discussion of AuxViews and camera models. And we described in the previous video that the term AuxView is actually short for auxiliary view. Some people also refer to these views as bounce views because when we draw from them we will be bouncing a ray off of the AuxView and into the modeling space. And in this first segment of this video we're going to be describing how to control where that ray intersects in the modeling space. When you use the standard SketchUp drawing tools, you are also projecting a ray into the modeling space. In this case, the view that you're the current view orientation, you're moving your cursor around in a viewing plane and you're projecting a ray into the modeling space. If you don't have any geometry that intersects that ray, then the resulting geometry will be created on the XY plane, or the plane of the red and green axes. So if we look at it from the side, we can see that it lies in that XY plane with a z=0 plane. The same is true of the GeoSketch tools. If you do not put your cursor into an AuxView, if you just draw an empty space, and you have not set an altitude or working plane, then as the tooltip describes, you're going to be drawing on the z=0 plane. But in the GeoSketch tools we also have the ability to set our working plane to a given altitude, and our prompt tells us that we can hold down the Alt key to set the altitude. It actually works in 2 ways. If we want to measure the height of a building, you hold down the Alt key. If you just want to key in an altitude, you can just tap the Alt key and release it, and then key in your altitude. So we'll key in 300 feet. And now when we draw geometry, it won't lie on that z=0 plane, it'll lie in the plane where z=300. And the same is true if we project rays from our AuxViews. We can see from our tooltip that it's bouncing the ray from the AuxView to a plane at altitude 300 feet. So next we want to illustrate the importance of correctly setting your altitude plane. So I'll draw a large block about the size of that city block and use the push-pull tool to project that up. And now I'll draw a line which represents a ray from the AuxView into the modeling space that intersects that block, but I'll just draw a static line. And so I'll just create a point in the AuxView and then a point on the face, and we can see that that represents a ray that intersects the top face of that block. But what we can see is if we use the push-pull tool and we move the face of that block up, the place where the ray intersects is moving. It's not only moving in Z because we're moving the top face of that block in Z, but it's also moving in X and Y because the ray is intersecting at a different location. And this will be true when we project our ray to construct geometry from AuxViews, and that's why it's important that you set that AuxView to a correct location. In the previous video we discussed finding the ground plane of your AuxViews. We prefer to use the term working plane or altitude plane because these AuxViews are oblique images of the real world, and in the real world the surface of the earth is not flat, then there is not a flat ground plane. Now you can think of having a local ground plane which may apply to just one building. So for example, if you had very hilly terrain, then the ground floor of this building would be at a different elevation than the ground plane of this building. So you can think of it as a ground plane, but it's important to know that depending on your modeling circumstances, the type of terrain that you're working with, or the fidelity of the models that you're building, it is not true that there's a single ground plane for your entire modeling space. So in the next 2 parts of this video we'll describe 2 different scenarios. In one case you do not have a nadir image to use to correlate your AuxViews, so you need to use only the AuxViews for establishing your scale and your position in the modeling space. And then in the third part we will have a nadir view, and we'll use a different technique for correlating our AuxViews to the working space of that nadir image.